And so we're going to go through some of them. We've kind of lightly touched on this addition already. So that's where we can add things together or concatenate strings. So if we assume that we have these variables, so we have a variable called A and we have assigned it number 1, B is number 2, C is 3, D is 0, and F is a string called maybe. Slides that Deb, like, used to work here, made. So if we said that an integer result is a variable and that is A plus B, then it equals 3. Make sense? So if we had a string result where we say Carly Rae Jepsen's one-hit wonder is call me, and then we concatenate the word maybe at the end. All right? People follow with that. So the plus sign will concatenate strings. Okay, another one that you can do is division. So if you have, assuming that same case, right? So 1, 2, these are the variables. So result of C divided by B would be 3 divided by 2 equals 1.5. So some languages might truncate to 1 when assigning a float because it doesn't have, if you've gone from a whole number. But in this case, Fiji will actually turn that integer into a float because we've gone from whole numbers up here to a float result. But, you know, do assume, and you should try and give it decimals if you want. That would be the take home. Other advanced things is these things called logical tests. So, you know, less than or less than equal to. So, you know, literally the less than sign or together, no spaces between. You just put the less than equal to or greater than equal to. This, so we've already used equals, right? We've said my name is a variable and that equals something. So we can have this thing that's like is equal to. So that's double equals, and is not equal to is exclamation equals, not equal. Does that make sense? So we're not defining it again, we're just saying, like, if we said my age is 100, and then you said, is my name, or is my age equal to 100? It would resolve to true because you defined it, right? Then you can have 2 ampersands, and that's the Boolean and, or you can have these 2 pipes, which is the Boolean or. So, what does that mean? Pictorially, you could say A or B, doesn't matter. Any part of that Venn diagram is A or B. If you said A and B, well, then it's only the bit that both of those things overlap, right? Or you could say A and not B would be just that and not that. So, this is where it does tend to get a bit complicated. So, yell out if you have questions. Happy to be interrupted. But you're following the same set of values that we're assuming here. So if we said A is greater than B, so 1 is greater than 2, that's false, right? That results false. But most of the time, you're going to have lots of these conditional statements that you want to, you know, nest into each other. So A is more than or equal to B, and C is more than B, or D is equal to 0. So that's our statement. So if we resolve that down, well, that's false, and that's true. That's true. So we're saying false and true, we'll cover this later, will equal false, but or this thing's true. So because this case is true, the whole thing resolves true because we've used or. And then even, you know, more complicated if we move the bracket so that it was this, so this is false, and this or this, well then it equals, right? People still kind of follow. This is getting pretty high level stuff. We'll go to like how many slides we're going to need soon. But this is important because you have to know these things to apply them later on. So use the parentheses carefully. Consider holding each thing into a variable. That can also help. So rather than create these lovely, horribly readable things, you could do them step by step to help your brain follow, which is what we're trying to do here in the by showing what this equals to. So we have these conditional code Booleans that we can use. There's a true or false statement that we covered just in the previous example. It's on or off, yes or no. So true is always assigned a value of 1, false is assigned a value of 0. So you could use this in a dialog box. So you can have a checkbox in the dialog that pops up. Do you also want to save the image output? Click it, equals yes. So if it's checked is equal to 1, it's true. If checked is equal to, or you could also say like unchecked is equal to 1 when it's false, and unchecked is equal to 0 would be a true statement. Like that? Depends on what you're asking, checked or unchecked. You can have an unlimited number of these in your macros. So remember that you can combine these ands or ors and things like that. So if we have this table where we have a variable of a, where here it equals 0 and b equals 0. So or false and false, then a and b is equal to false. If we say false or false, well then it's false. False equals false, well that's true. So false, false. If we said so false or false is going to be false. False equals false, well that's true because they are equal to each other, they're the same thing. And then false doesn't equal false, no, that's not true, that doesn't. So that equals false. Then if you had a false and a true statement, right? So you're kind of running the role of interpreter by reading that as false and that one as true. So when you have a false and a true, so then it would equal false because false takes precedence. If you had false or true, well then it would be true. False equals true, well that's not true. And therefore the opposite must be true. So false not equals true, well that is. We'll move to some text or some kind of more realistic scenarios. So if we have the number, we've got a variable x and we have it with the stored number 5 and y equals 10. So if we have a test 1 where y is greater than x, well that's true because 10 is greater than 5. Right? So the second test is y equals 2 times x. So in your head, you can resolve that. You can say, well, 5 times 2 equals 10 and y equals 10. So are they equal to one another? Yes. And then the third test, you can say, well, test 1 and test 2. So this was true, therefore it's true. Okay? And test 4, we could say 10 is greater than 5, and 10 is equal to x times 3, so 5, 15. No, that's not true. So then overall test 4 will equal false. So having the lack of brackets and things can make that hard to read. And these true or false are really useful for when you run the loops. So if a variable is less than the number of results you found, then only do it that many times. Right? So another thing that can be useful is getting the date and time. So, reporting when it was run. is really useful. And also you can have it apply to time how long a run took, for example. So there's a command, pretty generic, it's called get date and time. And it returns the date and time in a whole bunch of variables. So what this kind of, how you should interpret and read this is that it's, when you run this command, it's sort of like running, what's the year? And it defines it as a variable year. What's the month? Defines it as a variable month. What's the day of the week, the day of the month, the hour, the minute, the second, the minute. So if you, after this command, just had print year, it would say 2024. Right? And then there's this other one, get time, which gives you the time of the day in milliseconds. But if you have like start time equals that, for all your commands, end time equals that, and then what run time equals end time subtract. Right? So that's how you can use that. Which can be useful because different commands, and if you're trying to save time on a script, if you can take 10 seconds off a script and you're going to run that on a million images, that will add up. So it is good to know how long it takes to run. So exercise 2 is sometimes you want to collect general information. Report it to the log window. So report the current date, day, month, year, and the time, preferably in this format, to the log window on 2 separate lines, and report how long it took to do that. So hint, start time equals what I just discussed. Now, check your work, because one of my biggest bugbears with Fiji is that in the get date and time, one of the arrays or the values that it spits out isn't what you expect. I'm going to just bring up the answers again, then rather than we don't need the extended one. Okay. So the first thing that I would do is clear my log window, because you might have some crashes. So you might have like multiple, the date is, but then the time is where it crashed or something. So always good to do that. And then I said, I start time equals get time. Now this is it is a weird looking number. It's a big number because it's just the time in milliseconds from midnight. And you can run this one, get date and time. So who discovered the weird thing with the get date and time? Everyone saw month is wrong. So month is base 0 for some reason. Why? I've never got a right answer, and they're not going to fix it. I've asked them to fix it, and they won't. So you'd print something like the date is day of month, month plus 1, year. And then, for time, we put colons instead of slashes. But a key take home is that you have to have these pluses, because you're kind of concatenating it into a string and printing it out. And then I said, the time, end time is this. And as I said, I've divided it by 1,000 because it made it a bit easier. So if we run that, and wherever my log window is hiding.